Okay, so today we're going to work on two different problems. The first kind is a supermarket employee wants to construct an open top box from a 14 by 32 inch piece of cardboard. To do this, the employee plans to cut out squares from the corner and then fold up the sides to create this box. So think of it this way. We've got this flat piece of cardboard, and that cardboard is 14 inches by 32 inches. Can you visualize a flat piece of cardboard? Okay? So then the employee is going to take and cut squares from the corners. Squares, remember, have the same measurement on each side, and that square is an X by X length. Okay? So again, hopefully you can picture what's going on there. So those squares are going to be cut out, and it's going to make like this thing not here kind of. And what you'll be left with is this it almost looks like a cross or an addition sign with a kind of fat, wider thing. Can you see the addition sign that's left? And then they're going to fold it up on the sides. So they'll take each of these little flaps and fold it up. Fold up the flaps, and then they're going to create a box. Okay, so let's get a little lesson on how to draw these, although I'm never going to grade you on your drawing. I'm going to do this in pencil so I can erase it. This is how I make my picture. I start with a parallelogram. You remember parallelograms from geometry? It's like a rectangle that's tipped. So this is my parallelogram. Try your best to draw a nice little parallelogram. And then I extend the parallelogram to give the sides of the box, knowing that off to the side here, it's going to be perspective, the same length, but back further. And then I just connect those bottoms. So what I've created, and I could actually even draw this line on the inside here, what I've created is this box here that the store owner can put whatever he wants in there. Maybe he's putting a sheet cake in there or something. But again, I'm never going to grade you on your drawing, so please don't worry about what your drawing looks like. Just kind of get your best rendition of that box. And now we need to get some new dimensions. What is the height of this box? We don't know. It's what I'm cutting out, right? That's the height here, is that length of that square that I cut out, and we don't know what it is, so I'll put X there. Good? Does that make sense? Because that's going to be what makes the height is the length of the square that I cut out. All right, now, this side is no longer 14 because I cut out a square with a side of X and X. So that side becomes 14 minus the two X's that I cut out from each corner. Does that make sense? Okay. And then likewise, this long side will lose two X's itself. And so that long side will be 32 minus 2X. And what is X? X is the length of the side of a square that's being cut out. Okay, so the X is the length of the side of the square that I'm cutting out from each corner. All right, so we drew our picture. This is what our thing came down to. We drew our picture, folded our sides up, got our dimensions for our box. And we want to figure out what size the square should be in order to create a box with the largest possible volume. What the heck is volume? How do you figure out volume? Length times width times height. Beautiful. Whoever remembered that. So my volume formula is my length times my width times my height. I'm going to go x times 14 minus 2x times 32 minus 2x. Okay, so that is the function that I am trying to maximize. How do I know maximize? Largest possible. So I'm looking for a max. All right, before I take my derivative, I want to clean this up. Okay? So I am going to start with these two here, multiplying these two things together. And then what I do as I work through, because there's an additional x, and I hope this doesn't bother anybody, this is my shortcut. I'm going to do 14 times 32. So 14 times 32, 448. That's 448x. Where did the x come from? This x on the outside. So 448x. Then I'll do, so I did 14 times 32 times x. Then I'll do 14 times 2x, negative 28x, times x, so that's squared. Then I'll do negative 2 times 32, negative 2x, so that's negative 64x times x. And then lastly, I'll do the negative 2 times the negative 2, that's plus 4x squared times x, so cubed. Good? Is that good? Are you okay with my? And then, so that's my volume equation. I'm just going to clean this up just a little bit more. I'm going to move stuff around and combine like terms. So I'm going to write this as 4x cubed minus, what is that? Minus 92x squared plus 448x. All right. So when I maximize and minimize, when I do an optimization problem, I have to take the derivative. So now I'm going to go ahead and take the derivative and set it equal to 0. Okay, now I have just put myself in a position where I have a trinomial which might be factorable, but I don't feel like guessing and checking and going through the whole snowflake because these numbers are big. So to save myself time and headache, I'm going to use the quadratic formula. Yes, A is 12, B is negative 184, and C is 448. Does that make you mad? I'm sorry. X equals the opposite of B plus or minus the square root of B squared minus 4 times A times C. I ran out of room. That's in the formula. All over 2A. Yep. Yep. So remember the, sorry, this is terrible. You can hardly read this. But remember what the quadratic formula is. It's the variable is equal to the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. You don't have to memorize that. I will definitely put that on the board for you so when we use it, okay? So what can't you read? My messy here? Yeah. So that's minus 4 times 12 times 448. Okay, so I need to I'll rewrite it so it's more legible. 184 plus or minus the square root of negative 184 squared minus 4 times 12 times 448. Not that that's much better, still scrunched together, all over 2 times 12. Now I'm going to do the math. Okay. What I always do is I find this part first and get an approximate for that. Okay? So I'm going to go second square root. I'm going to give another parenthesis because I'm squaring a negative, and I want to make sure I put that negative in there. Negative 184 end parenthesis squared. Can you see how I'm plugging that in? So I did a second parenthesis on my calculator, made sure I put the 184 in parentheses to square it, minus 4 times 12 times 448, and then I hit equals, and I got 111.14-ish. So this is 111.14. That's what that thing inside of there is. So my math is 184 plus 111.14 divided by 24, and 184 minus 111.14 divided by 24. I'm going to get 2 answers. That's what this plus and minus is about. Add and subtract. So 184 plus 111.14, oops. I hit equals, I divide by 24. My first answer is 12.3-ish. Then I'll do the next one. 184 minus 111.14, hit equals, I keep missing an extra 1.14, hit equals, divide by 24, and I get my next answer. Let's go about 3.04-ish. Okay? So which one's the answer? I need it to be a max. But there's also another way you can tell the answer besides making sure on the prime chart.
The bigger number.
Well, if I try to cut out 12-inch squares off of each side, that would mean I've cut out 24-inch squares off of this side. Right. Is that possible to cut out 24-inch squares? 24 total, I mean, inch if I only have a 14. So I know 12.3 cannot be a reasonable answer. However, my prime chart will also tell me which one's the max by just doing my test points. So if I plug in, again, into my derivative area, so if I plug it into here and do my test points, let's say I plug in 0, I know that's going to be positive. If I plug in 4 in here, that would be 12 times 4 squared minus 184 times 4 plus 448, and I get negative 96, so that's a negative. And then if I plug in something on the other side, like 13 maybe, I'm going to get 12 times 13 squared minus 184 times 13 plus 448, and that one comes out positive. I just plugged it in my calculator. That one came out positive. So I do know it goes increase, decrease, increase. So there's another thing that shows me 3.04 is the one I want because I wanted it to be a max. And 3.04 is the one that's a max. So what's my answer? 3.04 inch squares. That's how so a lot of math on there, only one variable, but a lot of math on those. Okay? So let's do another one. Same problem, what changes? The numbers. Yeah, pretty much the same problem, only thing that changes are the numbers. So I am just going to jump right in on this one to my folded up form. I hope that doesn't bother you. Same problem. So this is my box that I'm making. Do your best drawing that you can by cutting out squares that are X in length.
Where'd you get the 2X from? It's kind of late to ask that.
No, that's fine. I'll go back up here and take a look at this. Remember, you're cutting each square, so I'm cutting it off of each side. So I cut an X off of this part and an X off of this part, so I'm cutting off 2 X's. One from each side. Does that make sense? Yep, it will always be because you're doing 2 X's. So this one would be 10 minus the 2 X's so that I have the flap to fold up. And this would be 16 minus the 2 X's so I have the flap to fold up. So when I write my volume equation, it is X times 10 minus 2X times 16 minus 2X. The biggest problem that I ever see people have on this type of problem is they multiply it and then they forget to do the derivative. So don't forget to do your derivative because that's going to mess things up. You're going to end up with some funky answers. So, what's that? No, you don't need to draw a picture. I'm not grading you on your pictures. I just draw it for my own personal, so I have placeholders for things. But if you just kind of get to a point where you remember what your stuff is looking like, that's fine. So this is 160x minus 20 minus 32. So minus 52x squared. I did the math quick there. I did minus 20x minus 32x, so that would be minus 52x times that other x, and then plus 4x cubed. I like to put it in the right order. And then I go ahead and take my derivative. And again, maybe this is factorable, maybe it isn't. I'm just going to not waste time trying. I'm going to do quadratic formula again. A is 12, B is negative 104, C is 160. So this is, my x will equal the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then I take my calculator and I figure out that guy. A lot of people ask, well, how can I plug this in the calculator? How can I just plug the whole thing in the calculator and get an answer? Most of our calculators don't have an option for the plus or minus. So there are fancier calculators out there. I can guarantee I've never seen anyone in here that has a plus or minus calculator available, so you do have to do it in the parts. So this is the square root of parenthesis for my negative 104 squared
56.
minus 4 times 12 times 160, and it comes out to be exactly 56. That means this one was factorable. But I can tell that the one before was not factorable because it came out as a decimal, an ugly decimal actually. So, but we're here already, so these are my two problems. 104 plus 56 divided by 24 and 104 minus 56 divided by 24 are my two answers. So 6 2/3 came out to be 6.6666. That's 6 2/3. And then Yeah, you can. Doesn't really matter. And 2. And so, again, there are 2 ways that you can check and see which one is your answer. One way is common sense, knowing that if I had 66 and 6 and 2/3 and put that in here, I'd have a number that's bigger than 12. 10 minus 12 is not possible. I'm not going to make a cake box that's going to be able to hold that. So 2 is the more reasonable answer, but I will always make sure, personally, I will always make sure on a V prime chart to see which one is the actual max by doing my test points for each of those. So I plug in 0 right into my derivative, I get positive. If I plug in 3, 12 times 3 squared minus 104 times 3 plus 160, I get a negative value. If I plug in something like 7, 12 times 7 squared minus 104 times 7 plus 160, I get a positive value. And increase, decrease, increase makes 2 the max. So my answer here is 2-inch squares. Okay, so that's problem type number 1. Is the supermarket employee open top box cutting the cardboard. Okay? Up next, we've got a graphic design artist. Yes.
What if it doesn't, like, you know how you do it?
Yep.
Like a map.
Yep.
What if it doesn't
Yep.
turn out?
So if it doesn't turn out to be a max for us, you made a mistake. There's some math error, and then you can go back. Either you forgot to do your derivative before you started plugging things in, or there was a calculation error.
So you should
But
always get the right.
yes, you should. But in the future, when you get into like calculus, then you'll be checking other values. You're checking endpoints to be a max or a min. So you would put on some other specifications that we don't have. We just don't get to that part yet. So I always just check and make sure that I have them. I just to get in the habit of doing it. Okay. All right. So next up, our graphic design. Graphic designer is asked to create a movie poster. It's got to have a 50-inch squared photo for the poster, surrounded by a 2-inch border on the top and the bottom, and a 1-inch border on each side. We have to figure out the overall dimensions for the poster so that the designer can use the least amount of paper. What are we looking for? A min. Yep. Least amount of paper, minimum. All right. So I'm going to sketch this out. We've got this picture that we're putting in here. And that picture is a border around it. So the picture itself has dimensions X by Y. And the picture itself, this picture that goes inside of here, that's X by Y, is already known to be 50 square inches. They told us that. So the picture, my colored part is the picture. Now I've got to figure out the border because the border is part of the paper as well. So they give me the specs here. It's got a 2-inch border on the top and on the bottom. So on the top, we're going to add 2 inches, and on the bottom, we're going to add 2 inches. And then a 1-inch border on each side. So on each side, we're going to add 1 inch and add 1 inch. That's going to give me new dimensions. So what's the new height of this poster? I've got 2 inches on top, a length of X in the middle, and then 2 inches on the bottom. X plus 4 or 4 plus X. Yep. Great. What's the new width of this photo or this poster? I've got 1 Y and then another inch on the side. Y plus 2. Yep, I've got 2 different variables in this one because it's not a square. It didn't tell me that it's a square. All right, so this is the total paper, agreed? So my area is my total paper, and the area would be x plus 4 times y plus 2. So what I have is 2 variables. Thank goodness they gave me a connector. X times y has to be 50, so y would equal 50 over x. And so that means I can replace my y with 50 over x. So my new formula is x plus 4 times 50 over x plus 2. I'll let everybody soak that in. Is everybody okay? Any questions? All right. So then let's multiply. I'm going to distribute that out before I do my derivative. What's x times 50 over x? 50. The x's cancel each other out. What is x times 2? Okay. What is 4 times 50 over x? 200 over x. Great. And 4 times 2? 8. Yep. So let's do a little bit of cleanup. A of x is 2x plus 200 times x to the negative first plus 58. All right? Where did that 200 times x to the negative first come into play? Yeah, I moved it from the bottom. Why? Because it's so much easier to take a derivative that way. Instead of me having to do the quotient rule with the x in the denominator, I can just move this up and do a power rule. And so when I take my derivative, a prime of x is 2 minus 200x to the negative second. And then that 58 zeroes out. I just did my derivative. You multiply the power in front. So that's how this becomes negative 200, and then minus 1 from the power. Good? Okay. Now, from this third line here, where I had 200 over x, to the fourth line, I wrote it as negative power because it was easier to take a derivative. But now that I have to solve, set it equal to 0 and solve, I'm going to put it back as a fraction because it's going to be easier to solve as a fraction. So I took that negative second power and moved it down into the bottom. So the only reason that I move it up and make it negative is to take my derivative and make my job easier that way. But then when I'm going to do the solving, I'll put it up on top. So I'm going to add the 200x squared, and I'm going to do a little slower solving on this one, equals 2. And then I'll multiply the x squared out. So 200 equals 2x squared. And then I'll divide by the 2. So 100 is x squared. And then I'll get my answers. In this case, it's plus or minus 10 is my value. Now, of those two answers, positive 10 and negative 10, is one an unreasonable answer? Yes. You can't have a dimension of negative 10. There's no way I'm going to make a poster negative 10 in length. So this negative 10 is not going to work. It's not a reasonable answer. And like I always said, I will always go through and do my prime chart just to make sure I did my math all right. So I'm going to put a 10 there. And I'll do my test points. If I plug in 0, I'll plug it into this guy right here. Ooh, I can't plug in 0, can I? Because that would be undefined. So I'll do 1. I'll plug in 1. 2 minus 200 divided by 1 squared. Definitely negative. Agreed? Okay. And then I'll plug in, I don't know, 20. So 2 minus 200 divided by 20 squared. That came out positive. So this is decreasing and increasing. It is the min that I wanted it to be. Now I have to answer, what overall dimensions are the poster? Overall dimensions. Well, x is 10, which would make y 5, yes? 50 divided by 10. But that's just the inside. So I have to add 2 to the y, and I have to add 4 to the x. So what are my dimensions? 14 inches by 7 inches. Great. 14 inches by 7 inches. So I got my x and my y. I got my 10 for x. Is that same reason? Are you good with that?
I see now.
Okay. Then I had to figure out my y, but then I had to remember that the dimension. So this one involves, the math isn't terrible, but it involves that like added step. Okay. So we're going to do one more like that.